This conference will now be recorded.
Okay, so guys, we're done with all kind of data modeling and reporting, right? We also covered one case on employee travel model where I built a beautiful dashboard, right? Now you understood, right, like how data analysis is done because you know the data, and we also did all types of analysis on the data. Okay, all right, now let's go ahead, and in today's session I'll get started with augmented analytics. Okay, augmented and predictive analytics. The next next, what do you say? Next 5 to 6 sessions, I'll be completely focusing on the augmented and predictive analytics. Okay, guys, you all have some understanding on machine learning, right? Anyone has got any understanding, at least the basics, the layman understanding about machine learning? Hello? Others? Come on, you need to respond, guys, because machine learning, I don't really speak about machine learning. If you all have no idea, then I'll go and start speaking about it. Otherwise, I'll skip that part because that has got nothing to do with SAC. Okay, so guys, I'll give you some basic understanding on ML. Don't expect me to cover what exactly is machine learning and all the in-depth concepts of machine learning. Okay, I'll just give you some basic understanding how exactly machine learning work, because right now this component, augmented and predictive analytics, is completely powered by ML. Okay, so augmented analytics and predictive analytics are two components of SAP Analytics Cloud, completely depends on machine learning. Okay, let's understand what exactly is machine learning. So first, let's understand what are the branches we have in artificial intelligence. Okay, so I got some beautiful blog on LinkedIn. Okay, so which explains it in a very easier way. Okay, so you can use this up. So guys, generally, if I go into artificial intelligence, we got like 6 branches in artificial intelligence. AI or data science, you got 6 major branches. One is machine learning. Okay. Second one, we call it as artificial neural networks or deep learning. Other way, we also call it as deep learning. So these are like the two big areas of AI, guys, where most of the innovations are happening on machine learning and deep learning. Then we got expert systems, robotics, NLP, natural language processing, and fuzzy logic. Okay. Um, So these are like the 6 major branches of artificial intelligence. So guys, if I just give you simple understanding about all these branches. Okay, so machine learning, what exactly is machine learning do in AI is? So you understand, right? AI has these many branches, 6 components, out of which machine learning is one component. So machine learning is is the only component, guys, which deals with data analytics. All data interpretations are done through machine learning. Okay, so machine learning. So you see, generally, guys, in machine learning, we get some algorithms. Okay, so we generally data scientists, what they do is they build some algorithms, ML algorithms. Okay, So using Python or R script. So majorly the language used to develop algos are mostly Python because of its extensive library. And also we some in some cases, like especially if you're building some statistical algorithms, you make use of R language also. Okay, I don't want to go into the details. You can go because this is not related for SAC. So I'm just giving only few understanding on ML, which is necessary for us in SAP Analytics Cloud. So it's a subcomponent of artificial intelligence that involves in development of algorithms and statistical models. Okay, so that enable computers to learn from the data and improve the performance over time without being explicitly programmed. Okay, so what happens is simply machines will actually learn from the data. They actually go work on the data, interpret the data, they learn from the data and make the decisions based on the data instead of relying on the human inputs. Okay, so that is simple way. In simple way, if I speak about machine learning, machines will actually learn from the data and make the decisions based on the data. Right, that is how your artificial intelligence is evolving. Okay, artificial intelligence or machine learning uses your historical data. It uses all the history to identify, suppose in customer in CRM analytics, it identifies the customer history, identify his behavior and detect the patterns of the customer, what products the customer going to buy. Okay, this customer will be going to repay the loans or etc. It is all based on the historical information. Okay, it uses the history. Okay, and maybe come up with future predictions or come up with some decisions on the data. One simple example I give is your OTT platforms, guys, like Netflix, Prime, right? So what exactly you do is, if you go onto the Netflix, okay, see, for a company like Netflix, getting a new customer is never a big deal for them, right? They are into HVLMs, right? High volume, low margin business. So these OTT platforms are in HVLM businesses. Means they have a high volume of customer and the money they make from one customer is very less, right? So for an platform like Netflix, getting new customers is never a big deal. So the success of an OTT platform always lies in the renewals. Okay, so how they making the customer stick and make their customer renew the products. Means the more the customer use the product, the customer will think, okay, I'm using the product very extensively, so it's value for money. If the customer believe he is using it and it's value for money, he will renew, otherwise he don't. Right, this is how the customer sentiment work in OTTs. So the success of an OTT platform always lies in how it's renewing the subscriptions, right? For that, it should make the customer use more and more of its platform services. So what exactly Netflix do is, so Netflix has these inbuilt ML algorithms which identifies what exactly the customer is watching. Okay, for suppose there is a customer who is watching more on rom-coms. So if he opens the default page, you see more of a rom-coms get pop up. If he is using sci-fi thrillers, so you'll see more of science fiction thrillers popping up. If he's watching more on action, okay, you see more of action content gets proved up onto his webpage. So means it will identify the customer pattern, customer behavior using the historical data. What exactly is customer liking? Maybe on weekends the customer is liking more on action, so they also see a lot of interpretations and gives you some suggestions on the content. Okay, so you see, right? So the basic website of Netflix differs from customer to customer. Once you log in, it changes, the content changes. So one simple example is machine learning. So machine learning use your historical data, guys. Okay, in terms of data analytics, okay, so this is one component of artificial intelligence, guys, which is heavily used in data analysis. This is the only component which is used in data analytics. Okay, machine learning is the only component of artificial intelligence which is used in data analytics. So in data analytics, like business analytics, I didn't say business data analytics. Okay, so it uses your historical data. Okay, so generally in analytics you have three components, right? Business intelligence, planning, and predictive analytics. In planning and predictive analytics, it's very simple, guys. It uses the historical data. It actually uses the historical data and predict your future outcomes on the data. In planning and predictive analytics, it is very simple. Machine learning will identify the historical data, use the historical data and predict you the future outcomes on the data. Okay, for suppose guys, you have a sales, you want to do some sales prediction. Okay, we make use of regression here. So where we use the historical sales data and predict you the future sales outcomes. Okay, you want to see the marketing trends. We use the historical data and identify the future market trend, right? So these kind of things is what we call it as regression, predictive analytics. And also for suppose you want to predict whether customer will buy our product or not, it falls into classification. It uses your historical customer data, what type of customers are buying what type of products, and based on that it will classify the customers, saying that okay, this type of customer will buy this kind of product. Okay, so whether the employee will leave the organization or not. Okay, so these all things can be predicted. So what exactly machine learning do is it has got some set of algorithms, guys. Okay, majorly developed using Python and R language. Okay, so these algorithms will actually work on the data. They actually work on the data. They learn from the data. These algorithms will actually learn from the data and come up with some outcomes based on the data. Okay, they come up with outcomes based on your data. So as machine learning, as machine is itself learning from the data without you writing the program. I repeat, as machine itself is learning from the data without you writing any manual program, so we call it as machine learning. Okay, so machine learning from the data and predict you or gives you some outcomes based on the data, future outcomes on the data. Okay, so so in one or other way, guys. Okay, so we are making the machines think like humans, right? So how humans do? Humans learn from their experience. We learn from the experience. Okay, and try to make the decision based on the experience, right? Similarly, machine learning is also same. It learns from the historical data and comes up with decisions based on the historical data. This is what we call it as experience learning, right? Because what is artificial intelligence? We want our computer to think like human, behave like human. That is what artificial intelligence, right? So machine learning is what we call it as experience learning, learning from the experience, learning from the history. Okay. Any questions, anyone? So this is the only area of artificial intelligence, guys, which is used in data analytics. Machine learning is the only area of AI which is heavily used in data analytics. You're doing any data analytics, guys, using some AI, that means you're using machine learning. You cannot use any other component in regular data analytics to predict something, to forecast something, to identify some patterns in the data. Okay, you want to identify some patterns and behaviors in the data, you will use only machine learning. Okay, so right, data analytics also has three subcomponents like business intelligence, planning, and predictive. In planning and predictive, in predictive analytics, simple guys, what is predictive analytics? In predictive analytics, machine learning algorithms will use the historical data and predict you the future outcomes. Simple. In predictive analytics, machine learning algorithms will work on the data, historical data, and predict you the future outcomes. Whereas in planning, so forecasting, guys, we also do a lot of forecasting, right? Future forecasting is done in planning. Earlier, this forecasting used to be a manual process, but now it is automated using machine learning. In SAC, we do the forecasting using machine learning. So we use your regular actual data and forecast your future values. So in planning also, it is used in one kind of forecasting only, predictive only. It is also for predictive only. So in planning and predictive analytics, machine learning is majorly used to predict or forecast your future values. Whereas in business intelligence, machine learning is used to identify your patterns in the data, behavior of the data, behavioral set of the data, patterns in the data. Okay, deep insights of the data. It is majorly used to decode your data. Decode your data. Machine learning is used to decode the data, identify the patterns in the data, identify the combinations in the data. Okay, and identify some hidden insights which cannot be seen through normal reporting. Okay, so that is done through augmented analytics here, guys. That is what we're going to start immediately. because we are in business intelligence, I'm gonna do augmented analytics, like how data patterns, how data behavior looks in SAC, right? So I don't think it's in SAC, or we also call it as data analytics, guys. I just said how machine learning is seen in data analytics. Simple words, SAC. SAC is like an end-to-end analytics product, right? So it has. Clear? Anyone? Any questions here on machine learning? So one simple example of machine learning is your OTT platform, guys. I'll give another example. I take Google Maps also, guys. So most of the people think Google Maps are real time. That's the wrong scenario. So what Google Maps do is, okay, for suppose you're traveling from point A to point B, okay. So what exactly do is it doesn't use satellite services all the time. Google Maps, okay, they use the satellite services to identify the traffic conditions, but ETA is never calculated through satellite conditions, right? There should be some formula running in the background. So that is run through machine learning. For suppose you're traveling from point A to point B at morning 10 a.m. guys. So what happens is this machine learning will use the historical data. Google Maps also runs on machine learning. It uses the historical data, identify the travels, okay, that happen between A to B on 10 a.m. in the morning. So it will take a lot of parameters. What time it is, what day it is, okay, whether it is weekday or weekend. For suppose if weekdays are very rush, uh, for suppose you're traveling from office to home to office, guys, at 9 a.m. or 10 a.m., which is like a peak uh, traffic time. So it will identify whether it's weekday or weekend, what time, okay, what type of vehicle he is using, two-wheeler, four-wheeler. So based on multiple parameters, it gives you, it calculates the ETA, okay. So, and also it uses some kind of live traffic and this machine learning historical data and live traffic conditions to forecast your ETAs, okay, your travel times, okay, travel minutes. So that is again, see, Google Maps runs through machine learning. I'll give simple examples, guys. You see airfares, guys. Airfare is always dynamic in nature. So high the demand, so more the demand for the fare. So obviously it goes up. Your fare goes up. The demand comes down, the fare comes down, right? It's like a demand supply kind of thing. Okay. So earlier days, guys, if fare goes up, the demand comes down. If fare goes down, demand goes up. So this is how the demand supply work. So right now, these companies implemented, a lot of companies implemented ML, where it has a target customers, guys, right? So if the company thinks this customer will buy our product at any given cost, they will go at high price for that customer. Okay. So right now, the companies are trying to strike a balance to sustain the demand at a high price. To sustain the demand at high price, and for that we use machine learning. Simple example is airfare. Airfares case, it will see how many searches happened for that travel in the last 3 months, in the last 3 days, whether it is higher than the average or below the average. So this is all statistical analysis is done by machine learning. And if the demand is on higher sides, it will obviously increase the fares. Okay, it will take some price hike. So this is also again done through machine learning only. It identifies the demand and takes the price hike based on the demands. There's a reason, guys. For suppose I'll give one simple suggestion. So when you want to fly, okay. So most of the people, what they do, they'll search through the apps, right? Like Make My Trip, or there are a few other applications, right, where you search for your tickets. Okay, if you search with an application, so your customer is registered there. You are a registered customer of that website. So if you make the same search 3 to 4 times on the same website, on the same application, mobile application, so now they know you are interested. Okay, or even you go to the Google and open multiple sites with same search also. So Google also, sell the data, right, to the partner companies. That is how Google make money. Your search data is all sold always, right? So generally, so they know the customer is tired, so they'll go for a price hike on the customers. So that's the reason it's always suggested to try your search in incognito, where your details are not maintained. Okay, do the search in incognito modes. Yeah, that's completely out of topic. Okay, this is how machine learning. So for demand plan, demand pricing also, we use machine learning. So I'm giving few examples like, okay, I also read one journal on what we say. You have cab aggregators, right? Like Ola, Uber. I read one article on Uber. So Uber in 2020 is clean. So when you open Uber, guys, you will see some auto sessions on the destination. You'll experience that, right? If you select that auto session, that means Uber is predicting your destination right. In 2020, they claim that they got 26% accuracy in predicting the destination of a customer. Imagine, cab aggregator is uh, what do we say? Understanding your destination. Right now, it will be at 50 or 60%. Okay, so what does it do? It uses the historical travels. For suppose you open Uber at 8 a.m. So it will see the historical travels happened at 8 a.m. And also you're traveling from location A. So it will use all the travels happened from A to what destinations he traveled from A. And at 8 a.m. what was the most frequent travel happened. So and it gives you it pops up some auto session. If you select that, that's it. So their prediction is correct. So they have 26% in 2020, guys. Now it will be 40-50. Okay, means 1 in 2 times you'll select the destination given by Uber. So this is again done through machine learning. It uses all historical data. It's very simple. It simply uses the history. Okay, so you all know, right? Future wars are all data. Future wars are going to be data wars. So because AI and ML majorly uses the historical information to generate all your outcomes or future outcomes on the data, future or current outcomes on the data. Okay, so you also might experience this, right, guys? So for suppose you search for any product in Google, and when you open Instagram, you'll all of a sudden you'll see ads populating on that product, right? This is all digital marketing. We are in the era of digital marketing, and that entire digital marketing is it's like a customer centric marketing is what they call, and that is done through machine learning. How that is done through machine learning? It uses the customer history. It uses the customer search history. You search something in Amazon, as you see that ad populating in Instagram, right? So it's all about your history. It's all about your search process. And once you buy the product, you'll all of a sudden you see ads stopped on that. So that is how it works. Okay, so this is all driven through machine learning. So machine learning is used everywhere, guys. It's used everywhere in data analytics space, because we are into data analytics area, especially in data analytics and business analytics. Means if I speak from an organization point of view, okay. So generally, it is machine learning is heavily used by the tech-driven companies like Google's, Meta platforms. These are tech-driven, right? They come with tech products. Okay. So in tech-driven companies, you see heavy machine learning, deep learning. They are heavily used. They do generative AI. They come up with a lot of innovative products. That's fine. But if I speak about a traditional company, I'm not speaking about tech-driven companies. If I speak about some traditional company, an oil and gas company, an auto component manufacturing company, they don't develop any tech products, right? They don't develop some new innovations there in AI. So what they do use is they simply use this artificial intelligence or machine learning in doing their own data analytics. Okay, so machine learning is one area of artificial intelligence which is used in the data analytics. Other areas are not useful in data analytics. In data analytics, machine learning is used in these three areas in this space. Okay, clear, guys? Any questions on ML, machine learning? I told you how machine learning works. I given few examples of machine learning, how your demand things work, your OTT platforms, your Google Maps, okay, your cab aggregators. These are like few examples like how machine learning works. Okay, okay. So you see some apps based on your history, search history. So this is all based on machine learning. And machine learning in data analytics is used in predictive analytics and planning to forecast your future values or generate your future values, and in business intelligence to identify the patterns in the data, hidden insights on the data, do some data diagnosis, give you more detailed insights on the data. Okay, because business intelligence is nothing but getting the insights on the data. So it's more about detailed insighting on the data. That is augmented analytics. right? What is general applications using machine learning and how machine learning is used in data analytics. Clear, everyone? Any questions on ML? Anyone, any questions here? So guys, I always suggest do your own research. This is not something I go and do detailing. If I start detailing on machine learning, I'll take at least 10-15 hours. Okay. So I just give you only the overall pictures. If you're interested, go do some detailing in use. You'll find a lot of content on YouTube. Right? So here, machine learning, we develop algorithms. These algorithms will work on the data and predict you all your future outcomes or give hidden insights on the data, identify the patterns in the data. Means it's all about the algorithm working on the data. Okay, these algorithms are developed using R or Python. Okay, so generally, guys, in for an organization, who develops this algorithms is a data scientist. So who develops these algorithms? Data scientists develop the algorithms. Okay, in case of an SAP Analytics Cloud, in case of SAC, we got inbuilt algorithms, guys. We really don't need, we are not data scientists. See, SAP Analytics Cloud consultant is not a data scientist, he's a data analyst. You're analysts. Okay, you get the data, raw data, and give some proper analytics on the data. That's it. So it's more about data analytics. SAC is more about data analytics. It's not about building the algorithms. It's not an AI platform where you can go. It's not an open source where you can go and build some machine learning algorithms using Python, right? So generally, what happens is, for suppose if there is an organization, they want to do some data analytics using machine learning. Okay, they don't have any products. So what they do, they buy some open source. Okay, they hire data scientists. They hire the data scientist, give him the problem statement. They give the data scientist the problem statement. The data scientist will build his own. What the data scientist do is, first he will explore. See guys, there are in machine learning we got a very big set of library, guys. A big machine learning library is available. A big set of algorithms are available in that machine learning library. Once a data scientist get a problem statement, okay, he will go identify which algorithm will fit into this, will can give solution to this, because he has got some understanding on all types of algorithms. So you will go and identify what kind of algorithms, whether it can be ARIMA, it can be others. Okay, so what kind of analysis needs to be done here? If it is more of statistical analysis, they make use of ARIMA models. So I don't want to go into ARIMA again. That's a different story altogether. Come back. So generally, what happens? What happens in general? For suppose your company has no product on machine learning, what they do? They hire a data scientist. They hire a data scientist. They give him the problem statement. So data scientists will use some open, there are some open sources which are free, of course. They might use it, or they get subscription. They pay and get an open AI platforms. There are a lot of open AI platforms where a data scientist can go develop some new algorithms on that platform. Okay, it's more of a Python platforms, guys. They come at free. Mostly it's free. Python libraries comes at free. So what data scientists do is based on the problem statement. So your machine learning has got a big library, a vast set of algorithms. Okay, he will identify maximum any algorithm fits for this problem statement. If it fits, he will pick that immediately. If it doesn't fit, or if it is partially fits, it will pick that algorithm, make some amendments onto the code of that algorithm, develop his own custom algorithm. Okay, he will develop his own custom machine learning algorithm, and this custom machine learning algorithm or a standard algorithm will work on the data and gives you outcomes on the data. So they feed the data to these algorithms, or they train we call it as training the algos, training the models. So this data will be exposed, historical data will be exposed to these algorithms, which is what we call it as training the algorithms or training the model, and they get trained and they give you some outcomes on the data. Right, 70 to 80% of the cases, guys, existing algorithms will work. So data scientists, you go and ask any data scientist guy, he says that 70 to 80% of the problem case statements can be done using a standard machine learning algorithms only. You don't need to develop some custom here. Okay. So what companies did was, okay, so everyone knows AI and ML are the future. So what organizations like tech organizations like Microsoft, SAP, what they're doing is they're coming up with the new age products like SAP Analytics Cloud, like DataSphere, like IBP. Okay, IBP and SAP Analytics Cloud, or even SuccessFactors Workforce Analytics. You might heard this. So these are like few products. Even in S4 HANA, also they're coming with an intelligent enterprise kind of S4 HANA system. So SAP is actually investing a lot on AI and ML. They're investing a lot on machine learning, especially. Okay, and they're coming with intelligent products, guys. So SAP is driving crazily. Don't think I really see a lot of people comes with 15 20 years of experience to my training. They still think SAP is ECC. They still think SAP is ABAP servers. Okay, SAP is BW. A lot of people still think warehousing means BW. Guys, gone are the days of warehousing through BW. Gone. They are completely gone. SAP is completely moving into intelligent products now. Okay, they're investing a lot on AI. You might not know, SAP has got around 400 to 500 data scientists working in their in-house R&D team. Okay, it's a big chunk of data scientists working there, developing new intelligent products which are highly powered by machine learning. So one simple example is SAP Analytics Cloud. You got IBP. You can go and ask the IBP guys also how forecasting work in IBP. It's all automated, all runs through machine learning. Okay, you can ask SuccessFactors workforce analytics how it runs. It's all through ML. Okay, so what happens is, so these tech product companies, right, like SAP, Microsoft, uh, I'm speaking from ERP standpoint. I'm not speaking from Google, Meta platforms. They are like tech product based companies. Like they develop universal products, not company specific products. They're not for company specific. They are for customer usage. Okay, if I speak from ERP standpoint for company usage, so the major companies are SAP and Microsoft. So they are investing a lot on AI and ML, and they're coming with the new age systems which are completely powered by machine learning. Okay, they're coming with a new age product which are heavily powered by machine learning, which has got a heavy machine learning library inbuilt in that product. So SAP Analytics Cloud is one product is having lot of inbuilt machine learning algorithms. Some are standard algorithms and some are custom algorithms developed by SAP. So most of them are custom algorithms developed by SAP and very powerful, guys. They are not developed by an ordinary data scientist. So the lot of powerful algorithms developed by SAP. So that a company, a normal company, normal XYZ company, instead of hiring a data scientist and giving him the problem statement and getting this, they can simply go and buy this product. Okay, this product has a lot of other components also, like reporting, data modeling, planning. Everything is there in this product. Along with that, it has got a lot of AI capabilities. So where he just feed the data. So here what we do, we have inbuilt machine learning algorithms. So we don't need a data scientist to build an algorithm. What we do, we get the data, we load the data into SAP Analytics Cloud, feed the data. So algorithms will work on the data and gives you all the outcomes on the data. It simply gives the outcomes on the data. So you don't even know what was the algorithm working in the background. System will pick what algorithm fits for that. System will pick. We don't even know. You don't need to go understand the algorithms and pick the right algorithm. Just upload the data to that predictive scenario, guys. System will identify the data pattern, what you're trying to achieve, identify what algorithm fits for that, trains that algorithm and gives you the best fitting model outcome. Feed the data, get the outcome. That's it. You don't even know what was working in the background. Okay. So a normal company, right? A normal product or manufacturing company or automobile or telecom company, they don't need to go and develop some new products, right? They simply make use of these heavy tech driven products. Okay. Okay. To run their day-to-day operations. Instead of hiring a data scientist and a big artificial intelligence team, they can simply subscribe to these products. Clear, guys? Makes sense? Any questions? Anyone? An algorithm part. First, I discuss what is machine learning, different applications which use machine learning in data analytics, and how algorithms are developed. In our case, we have an inbuilt algorithm. Okay, so guys, even I have a strong understanding on machine learning, I don't know what was the algorithm working in the background. I really don't know because it's not visible to anyone. Clear? Yes, I'm seeing a pin drop silence today. Any questions?
No, Satya, it's very clear.
Others, any questions?
No, Satya.
No, Sachin.
So here, when I speak, right, SAC has got inbuilt ML. A lot of people panics. They're saying that I don't have any understanding on machine learning. So you really no need to have any understanding on ML to work with SAC, because it will present as an option, guys. Just feed the data, some algos work in the background, gives you the outcome. That's it. And SAP is not even releasing the documents of what is the algorithms present in SAC. They're not releasing also. They didn't release also. For suppose even I'm a data scientist. I say so you take me. I'm not a data scientist, but I got a very strong understanding of artificial intelligence, machine learning. I underwent some trainings. We did some ML related work in our organizations, custom work. Okay, which was later moved on to SAP Analytics Cloud. Okay, so I have some understanding, not some. I have a strong understanding of machine learning, but still I don't know what was working in the background. Okay, because nothing was disclosed. So you really no need to have any understanding. Just feed the data, you get the outcomes. That's it. You should know that how to feed the data, how the outcomes are given, right? So you'll work more like a data analyst only. You'll never work as a data scientist here. So I say this very, very honestly, guys. AI is the future. Machine learning, deep learning, these are some components of artificial intelligence which will rule the future world, which will rule the entire future world. Now you're seeing, right, Gen AI, generative AI. I'll speak about generative AI also. Okay, get it? Gen AI is making a lot of buzz once Chat GPT was introduced. So generative AI is the biggest buzz thing, right? So they are the future. Okay, but you will not find data scientist roles in normal organization. You'll maybe if it's a tech driven company, they are coming with a lot of new tech products using artificial intelligence. Yes, you'll see a lot of data scientists working there, like SAP, Microsoft, Google, Meta platforms. Okay, some tech driven companies, Adobe. Okay, so who are coming with some new intelligent products, fine. But in a normal organizations like manufacturing, oil and gas, consumer driven, uh, telecom, uh, power utilities, normal, like 80% of the organizations, guys, banking. So you really don't see, because they don't develop any new tech products, guys. They simply use the tech products given by these organizations to run their day-to-day operations. So you don't see any data scientist roles in these kind of organizations much going forward, because so instead of hiring a data scientist, giving him the problem statement and do all this work, they have these inbuilt in the products. Just feed the data, get the outcomes. So you will not see a lot of data scientist roles. Very honestly, I'm saying it's only in big tech-driven companies. That's it. All right. So this is about the first branch of artificial intelligence, machine learning. Machine learning will have algorithms developed using Python or R. These algorithms work on the data, basically on the historical data, understand the data, learn from the data, and make some decisions based on the data. Means they will come up with future outcomes on the data, come up with some new decisions on the data. I'll give a lot of examples. Then comes neural networks, guys. Artificial neural networks is what we call, or we also call it as deep learning. Simple thing is deep learning. So ANN is kind of an algorithm inspired by human brain. It is like developing a human brain, artificial brain, guys. Okay, so it consists of several layers of neural networks. Okay, and produce an outcome. So which gives you, it's like the data passes through multiple layers, guys. Here the data passes through multiple layers. So information from one layer is used in another layer and finally comes up with an outcome. So simple example of this deep learning. So guys, deep learning and machine learning are combined entity. It's a combined entity. A lot of people think deep learning is different from machine learning. It's a combined entity because you need to have some historical data to generate the future outcome. Also, we need some historical data that comes from, again, machine learning. So deep learning is kind of ways combining multiple machine learning algorithms into one set. It's one or other way. You combine multiple ML algorithms into one set. First algorithm will feed data to second algorithm. It generates some output to third, like that. Data passes through multiple filtering spaces and comes up with the final outcomes, guys. Okay, so this is what we call it as deep learning, the next big thing in AI world. So guys, almost all the heavy future tech products are driven through ML integrating with deep learning. Machine learning and deep learning combined entity, uh, okay, will actually drive the next generation of artificial intelligence. One simple example here is ChatGPT. Okay, generative AI. So right now you hear a lot about Gen AI, generative AI, right? Where this artificial intelligence will generate the content. It will not search some content and give you that content automate as is. It will generate the content on its own, right? That is what we call it as generative AI. It's one simple example is ChatGPT. It's more of a Gen AI content, right? So that is again driven through ML and deep learning, machine learning and deep learning. We'll try that. You also see, guys, I'll also give you some one simple example. Instagram has a face recognition program. Facebook and Instagram, they run through a big face recognition program. Okay, means they have the facial features of each and every account holder. So whenever you upload any picture, guys, in Instagram of your friends, you'll see an auto tag session. Anyone experienced with this? When you're like a bunch of friends, you're uploading one picture, you get an auto tag sessions on Instagram or on Facebook. Okay, that is again driven through ML and deep learning. So Google Assistants. Okay, okay, your Google Photos, guys, photo sharing platform, Google Photos, one big example which we use in day-to-day life, right? So what happened on the same day? Okay, see, Google Photos also gives you an option, right? It gives you the most frequently seen photos and ask them to name that photos, right? If I name one photo, one person as X, so it will collate all the photos of that person and gives you a simple memory of that, right? It makes a simple video of that. So that is again Google Assistants. So this is again a combination of deep learning, guys. So these are like heavy new age tech driven products, right? So they all are developed using deep learning, machine learning with deep learning, combined entity. Okay, self-driving cars, one more best thing example, Tesla, self-driving cars. Okay, self-driving softwares are developed using deep learning. So this is one area, guys, where you'll see lot of new products coming in, but we are in data analytics space. We don't really need deep learning. This is used, I told you, right? Deep learning is you see only in the companies, okay, which develops tech products, technology stacks. You really don't see this deep learning in a normal organization. For suppose, guys, I'll take simple example, Tata Mahindra and Mahindra, guys. You see a new product, right? XUV 700. I don't know how many of you know. You know this, right? XUV 700. It has got a self-driving option. Do you think Mahindra and Mahindra developed that software? No, it was not developed by Mahindra and Mahindra. It was developed by an organization called KPIT. Okay, so they developed that, and this purchase Mahindra and Mahindra purchased that software from this, and they integrated into their own ecosystem of that product. Okay, so that's self-driving softwares and car softwares are now developed by the OEMs, guys. They don't, okay, OEMs means these automobile companies don't develop that software, self-driving car softwares. It is developed by some tech company which will be sold to this. Okay, they'll have some patent rights and they'll be sold for every vehicle they use this software, they need to pay this much amount to the tech company. Same with Tesla also. Tesla never developed in-house softwares. It is outsourced only. So you'll see this deep learning kind of things in a heavy tech-driven organizations only. Okay, which is developing some new softwares for the future. It's used everywhere. Then we have expert systems. Expert systems is, guys, anyway, we don't need this much understanding, but I just want to give you some understanding. I know I'll be wasting 20 minutes of time and giving you insights about all these things, but you should understand what are the all branches of artificial intelligence, what is machine learning, so that it gives you, when I'm using it, right, you'll not be an alien. Okay. So expert systems is one thing. I'm going at very layman level. You can dig deep. Okay. Expert system, it is like an industry specific or field specific, guys. Okay. So it has a heavy knowledge base. Expert systems, we upload a heavy knowledge, means we give all the rules, regulations. Okay. Especially, I'll give a simple example, guys. In bank, I want to identify the financial frauds. So to identify the financial frauds, so you need to understand all the rules of that financial institution. You should know all the rules first. If it is any rules get deviating, then it's a fraud, or then it's a risk. Okay, any one rule getting deviated, it's a risk. So this, we load all the knowledge base, collect all the things, all the rules. Okay, and we have an inference engine in expert systems where we apply all the rules on that inference engine. Okay, and if you pass any case, is one simple example. Customer risk profile, you want to identify the customer risk profile. Okay, so what do? You have a big rules of all the things, whether customer has all the KYCs done or not. Then the customer, what is the customer's loan history, how much percentage of loans he cleared on time, the customer's employment, do he has any breaks in that, whether his employment is going up, down. Okay, if it is business, how his business turnovers are going ups and downs. So it will have all the things. So it will pass. You want to, bank want to give a loan to the customer, first it will say KYC is done, yes, this is checked. Then second, it will go to the second step, history, this is good. Then it will go to the third step, fourth step, fifth step, and if it is all good, then it is customer is in green, you can give it. If there is any deviation, it will give, okay, at this step there is a deviation. So it's like in risk identifications, fraud identifications, we make use of these expert systems. Okay, even for diagnosing the cancer, guys, you identify the especially expert systems you've seen using in financial institutions and also in medical industry. It is majorly used in medical and healthcare industry to diagnose your disease, to identify what exactly it is. Okay, so you load that medical history of that. So what patient is facing. So based on that, it will try to rule out what kind of disease it can be. So cancer identifications, it's majorly used to identify the cancers and everything. You have seen diagnose and treat cancer, help financial institutions detect the frauds. Okay. So it's majorly used their expert systems. Simple example is IBM Watson. One product which is part of expert systems is IBM Watson. As you, IBM Watson came into headlines when it defeated a chess champion. I don't know the name of the chess champion. It defeated one chess champion. Means IBM Watson, to test what IBM did was they're given all the rules of chess making to this product. Okay, and it played with one. Okay, I think one of it, I don't know what his name is, and it won. Okay, so that's how IBM Watson came into limelight. Then you know robotics. Everyone knows what exactly is robotics. Okay, it's like automating your human work, right? So right now in most of the manufacturing companies, machines are doing all the automation. Okay, so we don't have a humans at all. You go to any warehouse, guys, packaging is done by the machines, passing and everything. These are all machines, right? That's all robotics. So everything, the entire human work is automated using robotics. You all know robotics. I'm not going into the details of robotics. Right now, it's AI enabled robots are coming. AI enabled machines are coming, right? Okay, so one simple example is your vacuum cleaners, your floor cleaners, right? So these are like comes from this. And then you've got NLP, guys. NLP, natural language processing. Okay, where NLP identifies is if a user or a customer speak in natural language, English, system identify, interprets that language. Okay, decodes what exactly the customer is. It will convert that natural language into a machine language. Okay, it will actually decode, convert that into a machine language, and again comes up with an outcome, and again that outcome will be converted into a natural language. Okay, one simple example is all your voice assistants like your Alexa, Siri, right? So they all are concepts of NLP only. Okay, guys, right now you see most of the chatbots are developed using NLP. So right now the entire customer space, there is a heavy revolution coming in the customer space, guys, right? So earlier, so customer is raising some complaint. It used to be like a person asking a lot of questions, right? But now it's an automated chatbot. Okay, so where you see an auto questionnaire based on your answer, the next question will differ. Next question will differ based on your answer. So right now most of the organizations, they are going away from human centric customer care to a machine based customer. It's like they're building a lot of chatbots as part of customer care, employee experience. Customer experience is now done through chatbots, right? That is all driven. The entire chatbots are now built using NLP. This is also one area to look for a lot of thing happening. So right now, most of the happening areas in AI are machine learning, deep learning. Machine learning is commonly used, guys. This is used everywhere. Machine learning is one thing which is used everywhere. In any company, you see machine learning. Okay, this is the most common thing you see it anywhere. So right now, most of the heavy tech related products are developed using AI, is developed using neural networks, and most of the companies are completely automating their entire chat frameworks using NLPs. Okay, these are the three areas where you see a lot of things happening. Physiologic, even I don't have an understanding, guys, for what exactly is physiologic do. It gives you how good you're true or false, or like what's the degree of true, degree of false. I'm not sure what. I didn't really see anyone using physiologic, so you can ignore it as of now. So these are like some areas of artificial intelligence, which you see six branches of artificial intelligence. Right now, machine learning contributes 80% of your AI revenues, guys. Right now, machine learning is one component contributes 80% of your AI revenues. Okay, remaining all contributes 20%, but down the line you see a lot of contribution come from neural networks and NLP also. Okay, these are in high growth phase, and machine learning is used everywhere. Okay, so SAP Analytics Cloud also make use of one component of AI. Only one branch of artificial intelligence is used, that is machine learning. Because I told you, right, machine learning is the only area of artificial intelligence which can be used in data analytics. You see, others cannot be used anywhere in data analytics. Can you do any you build any chatbots in NLP? No, right? We never build any chatbot in NLP, in data analytics. Sorry, we never built any chatbots in data analytics. We don't automate anything through robots, right? In data analytics, we have nothing, no rules and regulations in data analytics, right? It's physiologic, you can straight away ignore. So only area that can be used, so in data analytics, we have data. We need to do the interpretations on the data, and that is done using machine learning. So this is the only area of AI which is used in data analytics. So you see only machine learning in SAP Analytics Cloud. Any questions on this, the branches of AI, and what exactly is machine learning? Anyone, any questions? I have this blog, guys. This is the URL for this blog. You all clear?
Yeah. And Satya, if not now, going forward, do we need to learn any Python or R scripting?
No, man. If you are in SAC, no, you cannot build any algorithm in Analytics Cloud.
Okay, for simple searches and all, for generative AI kind of things, we don't do anything, right? Here, as of now, we
One
don't
thing,
know.
SAP Analytics Cloud has inbuilt algorithms. but you cannot create anything new. There is no option to create a new algorithm in SAC. It's a product, right? You cannot build any new algorithms in a product. It should be a platform where you build the algorithms.
Right. But in SAP data intelligence, I heard they need some Python like that. Any idea on that?
So that is to build a data pipeline, not build
Yeah.
an algorithm. Python is not only used to build algorithms, right? Python used everywhere.
Okay. Okay. So
Python is
to build
a
pipelines.
programming language, simple programming language. You can develop anything using Python.
Okay. 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 Okay.
So
In that sense, they need it there.
to build some data pipelines, because data intelligence, yeah, it's a good question. So data intelligence is one product. I
And
clearly
Satya, if you
mentioned.
don't feel it is irrelevant, I have one basic doubt. Can I ask you here? But maybe it's out of context or something. It's regarding DI.
Data intelligence.
Yeah. Actually, here, what is the basic difference between data intelligence and data sphere?
You see here, man, I told you already. This is.
And that's what I didn't get actually. In data
You
intelligence,
see this, right? So data intelligence was more of an ETL, where you make data pipelines, where you connect with external systems, make the data pipeline from an external system and load the data into your target systems, right? It's more of an ETL way. Okay. But earlier we have a lot of ETLs, guys. Like we have SLT for real-time loading,
right.
data services like bots, DODS for
Right.
periodic loading. So it's all going away there. Everything is, and we have cloud-based ETLs to load cloud application, to load data into cloud applications like CPIDS, CPISDI. And for on-premise, we have separate ETLs. So right now, it's SAP is removing all ETLs. Not removing, they are moving away from all ETLs. It's like one ETL, one data intelligence is one product where you, from which you can load data from any system to any system. Source can be anything, target can be anything. SAP, non-SAP, on-premise, cloud, no worries. You can build
Okay.
a data pipeline from any system to any system in the universe using data intelligence. You want to load data in real time, periodic, anything, in any kind of data load is done through one system. It means like one product to build any kind of data pipeline.
Okay. The basic functionality of SAP DI is ETL, right?
It's majorly ETL.
And data sphere also we are doing ETL, right? We are getting data from this one.
So it's an inbuilt ETL in DataSphere. We see any system staging the data should have inbuilt data loading, right?
Okay.
Even SAP Analytics Cloud also has inbuilt ETL.
Very minimal. Okay.
Okay, where you can load the data into SAC also. Right. So makes sense, right? So here, so this is about all 6 branches of artificial intelligence and machine learning. Okay, guys, any questions? Anyone? I'm not. It's not bouncing off, right? You want to do some, so you can start your own research on top of this. Means you can use this as a base and start working on it.
Yeah.
One small question here.
Mhm.
In Python, we have data analytics, and in SAC, both are same or both are different, conceptual wise or etc.
No, man, I don't want to go into Python analytics. That's different.
That is totally different. Okay.
Python, you have library, man. It's a library. It gives you library. A lot of functions. You need to use that function code to get develop a report. It's, to build any chat, right? You need to write some kind of code there. Here in SAC, you don't write any code to build any reports, right? This is product. That is script. Different, complete different things. All right. So if I go on to this machine learning things. Here you see, machine learning is like a field of study that gives computers to learn without being programmed explicitly. So they learn from the data. So generally what do you do in traditional computing, guys? You write a program in the computer, feed the input. Okay, the code logic will get executed and you get the output. So here what do you give the input, and also for this input, this is the expected output. And you expose the data to the computer, which is having algorithms, machine learning algorithms. These algorithms will work on the data, get trained from the data, identify the relation between inputs, expected outputs, and come up with the logic out of it. Call it as model in general. You can also call it as program also, but generally we call it as model. Outcome is always called as model. And this is how your traditional programming works, and this is how your machine learning work. I'll give a simple example, guys, of predictive. I'll use one simple example of predictive analytics, how it is done. So suppose I have a students marks and result. I'm going very basic example. Students and marks. Okay, so you got some first semester result. What do? I'll feed this data to this algorithm where I marks as input and result as expected output. Means for this mark, this is the expected output. So this will be exposed to the algorithm. So these algorithms will work on the data and comes up with a model saying that if marks is greater than equal to 4, it's saying pass, else or less than equal to 4, it's saying fail. You do the data bucketing here as a model. Then this model will be validated with few more data records. For suppose, guys, you feed 100 records to SAC, you take 80 records for training purpose. You take 80% of the data for training purpose, 75 to 80% data. Okay, where it trains the algorithms will work on the data, identify the relation between result and marks, and gives you an outcome out of it. The remaining 20% data is used for validation, identify the accuracy of your model. To identify the accuracy of the model, it will use the remaining 20% data. Okay, so for this marks, it has the actual result, and these marks will be fed to the predictive model. You get predictor result also. So suppose here, even 3.5 is also pass. Okay, even 3.5 is also pass. But predicted result will be fail only, guys, because it's less than 4. So it's fail. Okay, so it means I can say this model out of 4, 3 are correct. It will compare your actual result with your predicted result. Okay, it will compare your actual result with the predicted result and gets you the accuracy of your predictive model. So in this case, out of 4, 3 are cut, so my accuracy is around 75%. If you're not satisfied with the 75% accuracy, we'll retrain the model. We'll change some parameters. I'll show you how parameters are changed. We'll change the parameters and retrain the models, and we'll keep on retraining the model until we get the models with desired accuracy, at least 85-90% accurate. So suppose now I got this predictive model with 100% accuracy. Okay, fine. So then what do you do? From the second semester onwards, you just feed the marks. From the second semester onwards, just feed the marks, system will give you the results straight away. Feed the marks, system will give you the predicted result out of it. This is how your machine learning training. This is what we call it as training the algorithms, training and validation. Clear? Makes sense how ML works? How future predictions are done through machine learning. Some machines I already given, right? Google Maps, Uber. I also spoke about this. Face recognition programs, right? Pricing, OTT platforms. This machine learning lifecycle you can ignore. Fine. This is all about machine learning, guys. Any questions on this? Anyone?
No, sir.
Okay. So guys, machine learning is seen in almost all the components of SAC. Like it is seen in business intelligence, it is used in planning, it is used in predictive analytics. In planning and in predictive analytics, it is used to predict. See, obviously, it uses the historical data and predict your future outcomes. Earlier, guys, predictive analytics is done through some statistical R related models, but now, wherever you go, the entire predictive analytics is done through machine learning. Whatever product you take, wherever you go, the entire future predictions are now done through machine learning only. So predictive analytics is completely driven through machine learning. In planning also, guys, we generate the future forecast, that is also done through machine learning. Okay, in business intelligence, we don't generate any future numbers in BI. BI deals with historical data, gets you the insights on the data, which is used for decision making. I repeat, business intelligence gets the insights on the data, which will help the business users in making some new decisions. Okay, so in business intelligence, we have a concept called augmented analytics. Okay, which is powered by machine learning. So we have an area called augmented analytics, which is completely powered by machine learning. Okay, so augmented analytics is what we call it as diagnostic analytics, guys. Okay, so generally, reporting is descriptive analytics. Reporting is what we call it as descriptive analytics. Means we get the data and generate and show in the reports what's happening on your data. What's happening? You have some sales data, guys. We'll show what is your sales revenue, how it is sales revenue, trend of your sales revenue, which products are doing good, which products are not so doing good. So you see all that in a report, right? So means it gives you all the insights of the data. Okay, we call it as descriptive analytics, what's happening in your data. But augmented analytics is called diagnostic analytics, guys. It's a diagnostics. It do data diagnosis and gives you why it is happening. For suppose in a dashboard we identified, right, for one product the revenue is declining. So then what we do, we run some data, we will run data discovery through machine learning and identify what's the main reasons. We'll try to identify the reasons why the revenue is on a declining trend. So it try to give you the reasons why it is happening. Okay, and that is done through augmented analytics. Okay, I repeat, augmented analytics is like a diagnostic analytics. It do data diagnosis and identify the reasons for your outcomes. Okay, so this is like a new age concept in business intelligence, guys. So most of the people thinks business intelligence is simple reporting. Yes, right now in the business intelligence, along with reporting, okay, along with your descriptive analytics, we also have augmented, which is like a diagnostic analytics where we should do some data discoveries. Okay, any questions here, anyone? Okay, we don't predict anything future here. It's only all about the data discovery in maintain data dictionary. Okay.
Yeah, Satya, I have one question. For descriptive analytics and diagnostic analytics, the data set that we are going to use is same or different data sets?
Same.
With the same data, we are doing descriptive analytics and diagnostic
Same
analytics.
model, man. I'm going to use the same employee travel data to do diagnostic analytics also.
Okay, same analytics, same data set.
Yeah. So generally, augmented analytics is kind of a new age analytics, guys, in BI space. New concepts in BI space, and this is like the big buzzword happening right now in the market. Augmented, and only two products I clearly mentioned it. Out of the BI tools, only Power BI and SAC supports augmented analytics. Only two products, and I'm honestly saying Power BI has got very basic augmented features, very basic, not comparable to Analytics Cloud. Especially AI ML integration, SAC is top notch among all the reporting tools. SAC has got the best integration. See, SAC has got its own flaws here and there, Saila. Okay, there are some options in the other reporting tools not available in SAC. Click is very rich in visualizations, but SAC don't have that richness. There are a few issues here and there, but when it comes to augmented, SAC has the best.
Yeah.
So now, if I speak about augmented analytics, we also call it as smart assist features. So these are like your augmented analytics features in SAP Analytics Cloud. Smart discovery, smart insights, search to insight, smart transformations, and smart grouping. These are like the concepts, 5 features we have in augmented analytics, out of which major is smart discovery. Remaining all are very basics. Major thing is smart discovery, where we do data discovery and do all data diagnosis. We do the data diagnosis in smart discovery. Smart insights and smart discovery. This is the place where we do data diagnosis. That's it. Okay. Guys, out of which you already seen smart transformations, right? Where you see, while creating the data model, employee travel model, I applied smart transformations, right? System analyze the data and give you auto suggestion, right? What transformation can be applied on the data? You remember? You can apply
Yes.
split transformation there. It's given you authorization. You can apply extract transformation there. System identifies the data and gives you a suggestion what transformations can be applied on the data. That is what we call it as smart transformations. I already covered that. So smart grouping in click in not click sorry, in scatterplot chats. Okay, you remember I did grouped. I'll group it once again. That's okay. I grouped stores. Okay, I created a scatterplot chart when I'm creating retail sales dashboard initial days, and I grouped it using smart grouping. I'll cover it once again. Yeah? That is smart grouping. Just a moment, please. Just a moment. Right. So smart grouping is how it works. So majorly smart discovery and smart insight. So what I do is, maybe we are out of time, so I stop here. In the next session, I start with smart discovery. I'll try to cover the smart discovery and smart insights in the next session. Okay. Any questions, anyone? Okay, no questions asked. Guys, I don't have a session tomorrow. I got some other plans with some other batch, so no session tomorrow. We will be meeting on Saturday. Okay. So regular time only 7:30. Okay. On Saturday. So next session will be on Saturday.
Yes. Okay.
All right. Thank you.
Thank you.